And the agenda, we're just going to go through a brief introduction of the mobile challenges, and then we're going to concentrate on testing the end user experience and look at some problems and network causes, and solutions, what we can do, case study, looking at some websites and how to optimize them, look at CDNs, what they provide for us, and then we'll conclude. Okay, let's get started. The mobile challenge. Of course, everyone here has probably seen this chart 20, 30, 40 times in the past year. That's why we're all here. Mobile traffic is doubling every year from 2009 onward, and internet usage, whatever that means, is projected to pass desktop internet usage in 2014. Okay, 60% of mobile failures are performance-oriented, not functional issues. And Google found that for every second increase in page load time, it resulted in a 20% decrease in traffic and revenue. Now, this next statement is kind of hard for most mobile developers. The gold standard used to be 6 seconds, but now it is 3 seconds. I know many mobile developers are saying, no, that's not possible. You got too many issues involved to get down to 3 seconds. That's just not realistic. And that is true for many applications. However, that is the gold standard. That is what, as many have found out, that is what people are expecting, or at least would like to have happen. So that is the gold standard. That's what we should be shooting for, even if in some applications it's not realistic. However, it still is what we should be trying for. And we have to just own up to the fact that people out there are expecting their online mobile experience to be just as fast as their desktop experience. Mobile is slower, but it doesn't have to be. Let's take a look. Now, we did a survey, XBO Soft, for the state of mobile testing. We found that the ratio of developers to testers is 2 to 1. And plans for 2013, well, will make actually the ratio worse, because they're planning on decreasing testers relative developers. In other words, they're planning on hiring more developers in this coming year than they are testers, by more than a 2 to 1 margin. And since only 41% do performance testing and 60% don't consider the network when they do test, and 64% don't test in other countries where the network characteristics will be a lot different, since at a ratio of 2 to 1, they're not doing the testing that they should be doing. By not increasing their testers, they're just going to make the problem worse. And if you want to get a download of our full report, there's the website there, the web link where you can get a full copy of our report. And that will be on an email that we have sent out. So if you don't get it off this webinar, you can get it by email. Just request it from me on. Okay. Part 1, you did testing the device. You tested the high price phone, or mid-price phone, and a cheap phone. You used the Angry Birds app. That's what we used for the test, and we used the tool Quadrant to compare. Then we did testing the server. We used web page test to analyze the performance of the server on a mobile device. We looked at ways to speed up performance, particularly what we could do in the server. And today we're going to be looking at testing the network, and we're going to mainly use Schindler's Mobile Performance Report to test and compare the different networks. So that's what we're doing. And if you are not considering the network before you start developing, you are setting yourselves up for failure. And we'll take a look at why that is. Testing the end user experience. That is our goal. We want to test just like the user is going to experience our product. And the only way to really do that is to do end-to-end testing the entire product, not just parts of it that many testers only usually test part of the product, but we want to make sure that we're testing the entire product. Okay, let's take a look. Most people, testers, they start this way. They have their app on their mobile device, or they have their service on their website server, and they test it. And they do functional testing, security testing, usability testing, all that type of testing, and it looks pretty good. And 59% stop here and declare successful testing. But is that the end user experience? Well, first of all, they can have many, many different devices. You know, Android has 3,000 plus different phones and combinations and variations and derivatives. Same with tablets and OSs. You know, 2.4, 2.5, you know, 3.1, 4.0. You know, it seems almost endless. And combinations, you know, these numbers are way low. I mean, there's OSs 5.1, now we're 6. So it's just quite a bit is the. So it's very, very hard to test the full range.
Yeah, Alan, would you mind giving us your IDs on how many Android devices you should test on?
That's a very good question. We get that question quite a bit, because if there's that many different devices out there, you can't test on all those devices to make sure that your product works well on all the Android devices out there. So what you do, and what we do, is we come up with a subset of maybe about 8 to 10 phones that are representative. And how we come up with that subset, you know, first thing you got to do is you got to look at the market leaders for Samsung S3, Galaxy S3. You start there, and then you look at different screen sizes, all the way from the 320 by 240, all the way up to the tablet size, 1280, and so forth. And then you look at the different OSs, 2.3, 2.4, 3.1, 4.0, and so forth. And so we get about 8 or so devices that way, and then we look at your particular application and get another set of 4 or 5 or 6 devices that are key. So we have a set of devices that are pretty generic that we use for all testing, and then we get another 4 or 5 devices that are particular to the application that you're running. So, and that will give you a fairly good coverage, so you have a very high level of confidence that your application will run on most of the devices out there. Okay? So the next thing you want to look at is, you know, you're testing a lot of different devices, and that's good. But now you want to, that doesn't get you as far as you need to go. Many times you have a mainframe or a database that your website server accesses, and your company, you know, if it's being used on a daily basis, of course, they're not going to let you test against it, stress test against it, or your mainframe, your database. So what you have to do is you have to do some intelligent stubbing. You have to write some code that will simulate or emulate what the database returns. And if there's a delay, a time delay, you have to put that in there also. Same with other parts of your product. Let's say you're only responsible for a part of your mobile service, and somebody else is responsible for another section. So you have to get data from that other section. Well, you can't wait until they're finished. You have to start your section now, and you have to test it now. You can't wait for them to be finished. So you do the same thing. You do some intelligent studying, you service virtualization, so you take that service and you write code that emulates that service. But so let's say now you've done that. You're still not done. Many applications now are composite applications. What does that mean? Well, you get data and you get content from third parties, from other websites. You know, we sometimes get a map from Google or Yahoo or something, but you can't test accessing the third party per se. You can't stress test it. The third party will not appreciate you doing stress stress testing on their server when they're serving a whole lot of different clients. Many times there's a charge that the third party charges when they're giving you content, and you're not going to test and be charged each time you do that. So you have to do the same thing. You have to do intelligent stubbing. You have to write some code so that it emulates what the third party returns. And so now you have the third party, the main thing, and under construction areas. You've written some intelligent stubs for that, but you're still not finished. You know, what happens for stress testing? Well, you've got to virtualize maybe 1,000 users, maybe 10,000 users. You can do GUI emulation, but not for 10,000 users. You probably want to do a transport level emulation of that many users. And products like Roadrunner and so forth can do that quite nicely. But you're still not finished, even after you do all that. Still got the network virtualization. And this is the hardest to emulate. And you can't skip this step because most performance problems for mobile are caused by the network. So you have to really concentrate on, and that's what we're concentrating on today in this webinar, network virtualization. Because, well, you know, people are accessing your mobile service, and you have no idea what they're connecting to. Some are connecting through Wi-Fi, some are from 3G, 2.5G, 4G, but the 3G networks vary greatly from country to country, from service provider to service provider, and so it's very unpredictable, which causes many problems. So let's take a look at some of the problems of mobile networks that broadband really doesn't have. Okay, uncertainty. Now, you don't know ahead of time what network you'll be connected to. That's what we just looked at. You don't know ahead of time what the quality of the network will be. And when you're testing, it's very hard to repeat the conditions for testing because everything is constantly changing, especially in the global differences in network speeds and reliability. And so there's lots of problems out there, and sometimes poor performance has nothing to do with you. The poor performance of your mobile service is caused by the network. So the problem is that the customers don't care where the problem is. You will get blamed for poor performance, even if it's not your application at all, it's the network. So even though it's a network problem, you have to do things ahead of time to mitigate any problems the network can cause. Some other problems, well, let's say you deploy your application and there's problems. Well, you can't fine-tune it after it's deployed. You can't upgrade the bandwidth of the network. You can't upgrade the hardware in the mobile device. You can't put an accelerator into the CPU if the mobile device CPU is not keeping up with what you're downloading to it. You can't do many of the things you could do with it if you had more control over the device and the network like you can in a broadband or a PC. You can't do any of those things. And you have to realize that the mobile network is just shining a light on pre-existing problems. Okay, one problem, slow network speeds. Long, slow TCP connections. Slower speeds means that strategies that work for desktop or broadband connection will not work for mobile. For instance, let's say you have 20 connections, 20 things you download. Well, if you do them serially, which means one at a time, that can take a very long time. You need to make sure that you do things in parallel as much as possible. TCP timeouts. Well, some people say, oh, I got a timeout. Why don't I just change the TCP timers, increase them, so I don't get timed out as much. So I don't have to worry about retransmissions. That is not a good answer. changing the timers of the TCP connections is a high risk because those timers are highly tuned for other network issues, and they can cause very unexpected timing problems. So you don't want to touch the TCP timers. And also, if you increase them, you can cause your application timers to time out, which is actually a worse problem. But whenever you see TCP timeouts, you have a significant problem in performance. You have significant performance degradation. Okay, let's take a look at some of the problems in more detail. Latency. Latency is the time it takes to go end-to-end or round trip. You have a session initiation. You send a message across. It initiates a session. It sends it back a response. Log-on request. Comes back. Log-on reply. Comes back. Login page request. Comes back. Log-on page download. And back and forth and back and forth. You send something. Wait for the acknowledgement. Back and forth and back and forth. And you have session teardown and session close. Well, each round trip, it can be quite a bit. In broadband, well, it's not really an issue because each round trip can go 2, 3, 4 milliseconds, 1 millisecond even. So that's not really a problem. But if you have a broadband, a mobile network, each round trip can go from 2 milliseconds for broadband to 400 milliseconds for a 3G network. Well, 3G network with 400 milliseconds can cause a page load to go from 1 second to 30 seconds. That is severe. And jitter is not really well understood, but that's your latency variation over time. You think, though, that if the latency was consistent, maybe you can do something to mitigate that problem, but latency is not consistent. Sometimes it'll be 10 milliseconds, sometimes it'll be 1,000 milliseconds. So the jitter is very, very hard to plan for latency. The best way is to eliminate as many of the TCP requests as possible. Okay, now you have connection disruption. You're traveling and your cell phone connection is being passed from one cell phone tower to another cell phone tower. That can cause a disruption. Let's say you're on the street and you're walking down the sidewalk. A truck passing between you and the cell tower can cause packet loss and retransmission. Some think that bandwidth is the problem, but for the most part, I would say it's not. Latency is the problem. Packet drops with retransmissions are common, and you have to plan for it, expect it, and mitigate that problem. Okay. Global network issues. This is something that's not well understood by many in the West. We did quite a bit of testing in the USA, China, and in India. And we found that some phones, some browsers, and websites that worked fine in the U.S. did not work at all in India because the reliability of the networks was not the same. The cell phone towers are further apart, so the reliability was not as good. A lot more retransmissions, and did not work near as well. Another factor in the emerging markets is that the charging for data. We have in the West, many times we have unlimited downloads and so forth. But in the emerging markets, they charge how much gets downloaded. And how much gets downloaded and how much gets charged can vary greatly depending on the browser or phone. So you have to be aware of that what you're doing can cost a lot to your end user. And it's not just the size of the download. It can be the size of the download, how many connections are established, how many retransmissions, all these things can be charged so that you want to do everything possible to keep the size of the download down, the number of transmissions down, the number of TCP connections down, and keep it as low as possible so that the customer is not charged a lot for the data. And of course, speed can vary greatly depending on the phone, the browser, or the network. So, solution. What can we do? Well, let's take a look. Many say, well, how can we change our customers' perception so that we don't get blamed? No, that is not a good solution. And tragically enough, yeah, I do hear some people say that, try to pass the blame and complain that it's not their problem, but it is our problem. It's something that we have to deal with. We can't change our customers' perceptions as much as we must change our reality. We must think differently. We must say to ourselves, mobile is different from desktop, and treat it differently. We must develop for performance from the very, very beginning. Plan for it before you start coding. And just because you haven't experienced a big failure yet doesn't mean you won't, and you won't experience it soon. So you have to plan for it and expect it and learn how to mitigate its problems. Okay, plan ahead. It's critical that you plan for mobile service deployment very carefully. The network can make a problem an order of magnitude worse. And this is kind of funny, but it's not really funny. What happens if you did a great job, you have a great idea, you have a great service, and it gets well received in the marketplace, and it goes viral? Well, if your infrastructure cannot support it, then your successful mobile service can actually cause you more harm because customers, a large number of customers went and saw your service, performance was awful, your brand takes a big negative hit, and people don't come back. And many times you only get one shot. So if you get that one shot and you do a great job at developing your mobile app, and you can't handle, you don't have the infrastructure so that when you're successful and your product fails, well, that's the worst situation possible. And then plan to use service virtualization, which we touched on before. Let's take a look at that. We touched on service virtualization in the beginning, but let's just go over it real quickly again. You want to emulate the services that are hard to replicate during testing. For instance, third-party composites, actual in-use internal databases, parts of the application that are under construction. You want to write code that emulates those services and emulate the data that comes back from those services so that when you test, it is as close to the end-user experience as possible. You want to be able to virtualize 10,000 users. So you want not just a stub in those areas, but you want intelligent stubbing. And if you do this, you're able to test early, test often. This is the motto of all QA departments: test early, test often. So now we're going to look at network virtualization a little bit more closely here. Again, remember, most performance problems are caused by the network, and the network's the hardest to emulate. So you must use a tool. And there's many good tools out there, so let's take a look at some of the tools that are out there. Well, Apple, in its development kit for iOS 6, is a very good place to start. It simulates internet connections and bandwidth speeds. You can simulate a 3G network, a DSL network, edge, very bad connections, very good connections, etc., etc., etc. It's a very good tool. And it just comes with the developer kit. So if you're developing for iOS, you must use that tool. It's a very good place to start. Now, if you have Android or other devices, the iPhone with Nokia or so forth, then you can use the network catcher, Shenra, which works very well. It can capture network profile and environment connects anywhere in the world. Gives details on why the problems happen, and as a global library from all over the world. Works with VCAT, which is also from Shunra. Emulates the network profile, so that, and then it integrates very, very nicely with load runners. So we have user virtualization and network virtualization, and we're closely integrated and control the entire test from load runners. It's very repeatable, what if scenarios, very, very nice tool. And you can use that in conjunction with Protect a Mobile, Device Anywhere, some of these other tools that are good at doing virtualization. So, when you test your live network, well, you can't duplicate conditions, too many variables, actual conditions won't be consistent. That's why we say using a tool is much better. It's repeatable, you can vary the conditions, what scenarios, and so forth. So let's take a look at some of these tools that we just mentioned and actually use them. We're going to take a look at the Shunra, which offers a free service using the network catcher and VCAT products, and we'll analyze a mobile application on several networks. We're actually going to look at 4 different websites. And they have what's called an application performance report, and we'll use that to analyze the application, and it also has recommendations on how to improve the mobile application. Okay, here we have 4 different websites on 5 different networks. As you can see, we have a baseline using Wi-Fi. The second column is a 4G Verizon LTE connection. The third column is a 3G AT&T connection, which is a very good connection. The fourth one is a AT&T 3G network of fair condition. And then the fifth column is a 2.5G network. And you can see we have 4 networks here. APOD, Astronomy Picture of the Day, is one of my favorites. And you can see that for Wi-Fi or 4G, well, it works like a champ. It comes back immediately. However, when you go to 3G and then to a 2.5G, it doesn't perform so well. And you say, well, yeah, but look, the repeat view looks pretty good. Yeah, but think of how the astronomy picture of the day. I go to it once a day, and each day it has a different feature of some star or galaxy, a different picture. You know, it's very popular now. Most of the time you see with the Mars Curiosity rover. So each day is different. So each day is pretty much a first view. So if I'm on my mobile, it's always going to be that 8.2. So if you're on mobile, the 3G connection, you're not really that close to the gold standard, but it's still not too bad. Weather.com, same situation. It changes on a daily basis. So when you go to 3G or 4G, it gets pretty bad. And if you notice, look at the difference between a good 3G network and a fair or bad 3G connection. Almost double the time it takes to download. That's not uncommon. Bollywood Hungama, well, that's one of the favorite websites in India. And you can see they do not do very good when it comes to their websites. We're going to look at that a little more closely, how to improve those times, and it can be improved dramatically. Then you got Wikipedia.com, and you can see that repeat view is quite common for Wikipedia, and their times are very good. For a 3G network, boy, they're under 3 seconds. So for a repeat view, they are already there at the gold standard. And remember, Wikipedia, the content doesn't change as fast as the other ones, and there's a lot of repeat views, so they're doing pretty good. So let's take a look at, let's zero in on one of these 4 and take a look at how we can improve the performance there. First of all, the network characteristics. What Shunner does is they tell you the characteristics. And all these characteristics can be changed depending on your situation. In this particular case, we had for 4G, we had a 1% packet loss, average round trip 52 milliseconds. And by the way, these numbers were come up using standard 3G and 4G networks in the United States. So this is a typical network in the United States with a good 3G connection. Typically, you'll have 360 milliseconds round trip, emulated latency, and 8.8% packet loss. But if you look at the 2.5G, it's very typical in the United States to have an average latency of 900 milliseconds. That is huge. If you have a page that you're loading and you have, let's say, 10 TCP requests, round trips, and each one in broadband, takes a couple milliseconds, so you hardly notice it when you're on a broadband connection. But when you go to a 2.5G connection, that goes right away to 10 seconds, going from almost an immediate return to 10 seconds. So that can be huge, and it doesn't have to be that way. You can limit your TCP requests quite a bit with certain strategies. Okay, let's look at Hollywood Bangama. This is some of what you get for analysis. You take a look and you see for Hollywood Bollywood Hungama, it's 49 JavaScript files, 66 CSS images, 80 regular images, 2 Flash objects, and 40 items. I mean, that's quite a download for any iPhone or Android or Nokia phone. I mean, that's quite a bit to handle for a mobile device. And then it also gives you a waterfall of the components. You can see where you're serially in sequence as you're downloading things, what's in parallel and what's not in parallel, and it gives you each of those things so you can get a good view of what's going on. And then it gives you a performance score. Well, for Bollywood Hungama, they received a very low score of 54 over 100. And what it does, it looks at 25 areas where performance can be improved. Here I just showed 8 of those. Add, expires, headers. That means your headers, do they expire? Do you have time limit on them? Making fewer TCP requests. Hollywood Hungama got an F, 0. That means they found an enormous number of TCP requests that were unnecessary, that could be eliminated by doing certain strategies. And that can make a huge performance improvement by just making that change there. But they made their AJAX code, cacheable. That was good. They had many unsupported components that phones couldn't support, which caused problems. And then after they give you a score, they also give you another section that actually goes into detail and gives you recommendations of how to solve that problem. For instance, Hollywood Hungama, they got an F on DNS lookups. What does that mean? Well, that means that you have to translate the host name into an IP address. And if you're doing that on the fly, if you're doing that in mobile, well, that could take 120 seconds to over 400 milliseconds. 120 milliseconds to 400 milliseconds for each DNS lookup. Well, that's a lot. So you can eliminate that by careful planning. So it gives you a strategy of how to solve that particular problem. And if you go through each of those 25 areas and did the recommendations, you can dramatically improve the performance of your mobile device. So what else can be done? Well, CDNs, which are content delivery networks. And the goal is to serve content to the end users with the cheapest cost or highest performance. And usually the optimal situation includes both these goals are aligned. And so what it does, it's by optimizing delivery across local networks. In other words, instead of accessing data from the central server, the CDN parses out the request to the nearest server or the server with the highest, that can give you the highest performance. Let's take a look at a little more detail of CDNs. Okay, without a CDN, let's say you're in Dulles, Virginia. I live in Reston, Virginia, which is right outside of Washington, D.C. If we get a request from our server, and there are huge, huge server farms in the Dulles area. Let's say I get a request in Washington, D.C. for data on one of my servers. Well, it's fairly close, and I can service that request very, very quickly. What happens if the request comes from London? Well, it goes all the way to my Dulles site, gets the information, and send it back. However, the service to the Washington, D.C. site will be much, much faster. Well, because Dulles web servers, it may be under a high load at that moment. Maybe there's a lot of people downloading from that same server. The network at that moment may also have a lot of traffic at that point. So there's a lot of things that can happen that can slow down that request. However, with the content delivery network, what it does is you can replicate the data on your website, and you can send it with automatic replication to many other servers around the net, so that you're on a server that's on the boundary of the internet, that's very close in proximity to who's requesting your content. And it's web caching, and when the DNS does server load balancing, the CDN takes all these things into account. So it looks for the server that can deliver the highest performance. Most of the time, it's the server that's, yes?
Oh, in your opinion, who would be responsible for CDN? Would it be testers, developers, or?
Right. Well, usually the developers are not in charge of this or responsible for this. Usually it's the person who is responsible for your connection to the network. Your IT person that is doing the contract. They can contact their service provider, or companies like Akamai or Mobile CDN. Those are companies that specialize in providing content delivery and doing this balancing. And so that when I get a request from London, the data gets delivered from a server that's on the boundary of the internet, that's in a proximity very, very close. And so that the request, so the network is not bogged down with a lot, especially if you're doing a very, very high content, like a video or streaming video or a large file or something like that. The content can come from a server that's very close. You're not bogging down the network. There's load balancing on the servers, so it can really speed up the delivery of content. Now, when you marry this to mobile, well, that can really help, and there's a lot being done in this area. So improvements to watch for is better integration of CDNs to mobile networks. And like again, you can contact your local provider, service provider, or companies like Akamai or mobile CDN, and because they're making great improvements in this area every day. They're also doing things like traffic optimization. Now, you have no control over these things, but these are your service providers that are doing quite a bit to improve the mobile experience. Bigger pipes offloading to other networks, fast latency, optimizing traffic, and so forth. All those things are being done behind the scenes to make it the mobile experience much, much better. Okay, so what is the characteristics of a good mobile site, or what are the characteristics, I should say, of a good development team? Well, first of all, they worry about the end user experience ahead of deployment. After deployment is too late. Proactive engineering, making your mobile service fault tolerant. If you're talking mobile, you're talking about lots of faults happening. Trying for a 3-second response. That's the global standard. Being able to handle spikes in load. That is very critical. Performance standards, you should specify them in advance, not afterwards, and you should plan the topology of your servers ahead of time and understand how that works. And issues to consider at the beginning, well, again, I'm mentioning this over and over again, the 3-second response. I know a lot of mobile people balk at that. They say that's just unrealistic. Yet, try to make that your goal. And you have to consider, what if your service goes viral? Do not let success of your app be a cause for black eye for your company or company brand. Ask questions like, is it internal or external? Is it a paid service or not paid service? Capacity planning, revenue generating. Is your logo on it? If your logo's on it and it performs badly, your brand will be hurt. So all those things you need to consider. Okay, optimization strategies. Well, we covered this in our previous, how to reduce the number of TTP requests and how to reduce payloads. And you can go onto our website and take a look at the part 2 in the series. And we did cover these issues in much, much more detail. The optimization strategies of how you can minimize problems in the network. Okay, conclusion. Moore's law for computer power and storage. Well, everyone knows this law. Every 2 years, the computer power doubles and the storage capacity doubles. And that's been going on since 1960, 1955. I mean, it's just, every year I hear, it just can't go on. But every year it does. It's just amazing how that just continues. A very close corollary to it is Nielsen's law for internet bandwidth. It's pretty much the same law. It's the internet bandwidth is doubling every 18 months, and that's good. So the long term does look good. But in the meantime, it is not good. You need to test early, test often. And the best way to solve mobile performance problems is to prevent them. And if you wait till after deployment, that's too late. If no network performance testing ahead of time will lead to disaster. Okay. Thank you very much. Follow us on Twitter. And thank you for joining our webinar. And now we look for questions.
Thank you very much, Alan. This was very interesting. We got a couple of questions. The first question is from Bob, and he is wondering, do you have any resource for determining the representative devices to test?
You mean for if you want to test Android and you want to get
I think that's what he means. Yeah, there are 3,000 Android devices. How do you select which one to test that are representative for a group?
Yeah, well, first of all, you go with the market leader, Galaxy 3X Samsung, market leader. You start there. And then you look for different size. You pick different brands and you go for the large tablet size all the way down to the very small feature phone size of 240 by 320. Then after that, you try to get a good mix of the different Android versions. 2.3 and 2.2 and 2.1. Those are still the largest percentage out there, and those are the largest percentage of phones. So, I mean, it's a very, very hard decision to make. Do you take advantage of some of the newer features on 4.0 and 4.1, which means that they won't work on the earlier versions because the 2.3 and 2.7, they are by far the largest percentage out there right now. So every decision you make is a trade-off, but so you can get about 7 or 8 or 9 phones using those criteria very nicely, and then when you look at the particular application, you can pick another 4 or 5 phones, depending on whether it's it's a game that requires a lot of back and forth HTTP request, or something that doesn't require as much, and you can back and forth, and you can do some optimization and look at the phones that work best for that. So, and that gives you a little bit of a summary of how we chose phones to test with.
But there's not like an online resource that you know of where you can find these selections, or?
Not really, because companies that do that don't like to publish it. They want you to go to them. They want you to go to them to do the testing.
Okay, so you should hire us.
Yeah, I mean, there's lots and lots of companies out there that have done this, and no, they usually don't publish their. And also, it changes every month or two. New phones come out, new phones go away, new requirements. So that list is constantly changing.
Okay, I got another question, and let me rewind to audience. If you have any questions, please use the control panel on the right to ask them. We'll try to fit them in. This one is from Rajiv. He was interested if you could explain a little bit more about the difference you found executing the performance test in the different countries. I think you mentioned India and the US.
Right. Well, it was interesting. When we did tests the test would normally take about twice as long in India as it would in America. And the reason was because the networks were so unreliable in that we had connections that dropped on a regular basis. So we had to resubmit and do the test. We just plain lost connection. And so we tested in several different places. You know, we tested in Mumbai, we tested in Nagpur, right in the middle of India. And the network was much harder to test in India. And another thing about the Indian network is that it was very hard to calculate what was being charged. It wasn't just for data download. The data was not just a function of how much data was downloaded. It was a function of the data downloaded, how many TCP requests were done, retransmissions, and some other things that we couldn't quite figure out, but we're still working on trying to understand exactly how they charge, because our customers, you know, we want to make sure that we deliver content in the least costly way, the cheapest way to our customers. So those are the two biggest things: the downloading, kind of unreliability of the network, and the charging of data, and trying to understand how that data gets charged.
Okay, thanks a lot. We got 5 minutes left, so I have one last question, and I'll take my question for that. After these 3 webinars, could you give us an idea on how or where to get started with mobile performance testing? Should you start with the client or the server or the network, or combine all of them?
So that's a good question. I would start with the server because when you start the server, that is where you go to mitigate your network problems. And the server webinar that we did last time gives lots of optimization strategies. So when I start planning for mobile developments, I want to understand those strategies in the server very thoroughly before I start, so I can implement them at the very beginning, because that will make the device, that will make the network problems go much, much easier if you start at the server and understand all the strategies that you can do there. And then after that, I would definitely use the CDN to deliver content. And then I would try to, but targeting the device, well, that's purely a marketing decision. If you go for the high-end devices, then you're eliminating all kinds of low-end devices out there, which are the majority of the devices out there are the low-end devices. So that's a trade-off. Better performance, high-end, but you lose some market share. Low-end, you lose functionality. So that's a trade-off. That's hard. You have to make compromises either way. But again, re-emphasizing, I would start with understanding all the server optimization techniques and start there. That affects your mobile your device performance in the network, and it mitigates your network problems right from the beginning. Then doing service virtualization, so that you test what the end user is experiencing.
Okay.
So I hope that
Well,
gives an idea of what I would do.
yeah, that's very clear. Thank you very much for this webinar, Alan, and for the previous webinars as well.
Mm-hmm.
And I'd like to remind the audience that if you want to get an assessment of your mobile performance, if you're doing it right, get some ideas on how to help your strategy, please reach out to us. We're here to help. And I wish everyone a great day. The slides will be up on SlideShare, and a recording of this webinar will be posted on YouTube. All this information will be sent to you via email tomorrow. Thanks a lot, Alan.
Yeah, thank you, Jan. That was good. That was fun.
Okay, bye-bye.
Goodbye.